Oh, hello everybody. These are videos that are coming out pretty quick. This will again be part of a terminology and vocabulary playlist I'm putting together. Um, Again, these videos are for the start of a conversation, the ability for people to chime in, explain their thoughts. The videos will eventually be turned into a more refined playlist after commentary has been assessed, researched, the truth has been found, substantiated, and people can at that point in time go back to the work and brush up on anything they don't understand or point to certain aspects as uh, evidence in whatever they desire to use it for. So, this one is regarding the laws of light propagation. Propagation is, of course, the how light travels, how it moves. It is the fundamental laws governing the propagation of light, including the law of rectilinear propagation, the law of reflection, and the law of refraction. These laws, often described as geometric optics, explain how light behaves as it moves through different media and interacts with surfaces. Of course, the law of rectilinear propagation, the law states that light travels in a straight line through homogeneous, transparent medium. Okay? This will be challenged, of course, because someone will say there's never a truly homogeneous, transparent medium. Well, we do have a blending of gases which have mingled together into a homogeneous region. That's, homogenized milk. You have milk that is naturally separated when it comes from the cow, cream layers on top, and through homogeny to homogenize milk is to make it uniform. We should be able to agree that we have a relatively homogeneous atmosphere. We're breathing. We don't feel the differences. We don't walk into pockets of different gases unless we fall into pits or some container railway explodes and poisons our atmosphere. For the most part, we have a homogeneous atmosphere to breathe. This means that if light ray encounters a smooth surface, it will reflect if it encounters a boundary between two medium. It will refract, but it will continue to travel in a straight line within each medium. This will be an important part for later on when we talk about other laws. We have the law of reflection. This law describes how light behaves when it encounters a smooth reflecting surface. Everybody knows what a mirror is. Hopefully everybody uses their mirrors when they drive. A lot of people use their mirrors to put makeup on, fix their hair. Really doesn't need much more to discuss other than it has an angle of incidence. The light coming off an individual or the car behind you is going to hit your mirror from an angle of incidence. That's why you adjust your mirrors. It will then travel at that incident ray to be reflected at an angle of reflection, to your eye so you can interpret that reflection. It reverses the image that you see. You see a mirror image. You do not see the same image. That takes us into the law of refraction. The law governs how light bends as it passes from one transparent medium to another, such as from air to glass or from water to glass. It's known as Snell's law. Snell's law states, all the rules regarding the ratio of, might as well cover it, the ratio of sines of the angles of incidence of refraction is equal to the ratio of the refractive indices of the two media. You will have an incident ray. The refracted ray, the normal to the interface between the two medium, all lie on the same plane. These laws are essential for understanding how light interacts with matter and for various applications in optics, such as designing lenses, mirrors, and other optical instruments. But let's now talk about Snell's law. Might as well open up Wikipedia, and truthfully, let's just go right to the meat and bones of it. Anybody can open up what Snell's law is all about and read. You do have an angle of incidence of the ray. This is the light coming to a boundary between two medium. You have an angle of refraction. This is how it exits. Now with Snell's law, you have an interface and you have an orientation. Wonderful. The argument that a community puts at hand is because you don't have a solid interface between your origination ray, your angle of incidence, and your angle of refraction, that you can replace this interface with something called a gradient. Again, if you just watched my last video about a gradient, you will understand a couple of things. Gradients will have an orientation. If this interface is stretched out, if you stretch this line here and replace it with a gradient, that gradient has a duration. That gradient between the value of the first medium and the second medium will have a change in measure, progressive change in measure. Between the upper section and the lower section, there would exist a gradient, and the change in index of optical refraction, the IOR value, would be different in this medium from the medium that the ray exits. And the ray will exit as a ray. In between, there are ways to, through mathematics, calculate, through calculus, the progressive refraction that they would believe to have happened and represent it as a radius value. Now, this is all well and good. Now, this is actually acceptable from light from our celestial, mainly the sun, that interacts with the very edge of our atmosphere and progresses down to the surface of the earth. No one should deny that that exists. However, under this model, people will create a equivalent, a coefficient, and they will use that coefficient to justify that any path of light anywhere within our atmosphere, a horizontal ray of light traveling within our atmosphere, according to that thought process, by mentioning the mere word or the mere phrase, the vertical gradient. The vertical gradient refers to a direction. Okay, and if we have light traveling through our atmosphere, it has to A, have an angle of incidence, and exit with an angle of refraction. Okay? Or it's not refraction. If you're going to make a derivative from Snell's law in a mathematical equation, it has to work from the premises of Snell's law. An angle of incidence, starting with the angle of incidence and ending with the angle of refraction. If you plug something in the middle, you just don't ignore everything else. So when you get back to the laws, where is there the law of curved propagation of light? There is not. So, if anyone talks to you about the 7/6R coefficient for atmospheric refraction, they are talking about one of those R values being a radiused path of light. How? How do they justify every path of light? Because they believe light never travels in a straight line. Well, light can refract at angles anywhere. But if it never travels in a straight line, that's a half-truth. Okay, it can travel in a straight line. It can refract or reflect at an angle. And under a very, very specific set of equations, you can represent curvature to that line. By no means has it been justified as a law. It is a special set of conditions that has been overplayed. And it's overplayed for one main reason. Because it has to be put into a visualization program that compares a curved or a supposed curved surface of a globe with a supposed curved path of light. You cannot take angular refraction and make their program work for curved surfaces. You would have to know specifically where refraction occurs, a specific height, a specific distance. So what they put in is a cheat. It is something that's put in place because that's the best they can do. And it's been put in front of me that until someone can invent something better, this will have to do. No, that's not acceptable. If something is provably wrong through evidence that I've just placed in front of everyone to discuss, you don't have to accept it. You don't have to entertain using a program that claims it represents atmospheric refraction properly. Some people like to play down the claim. You're not considering refraction at all, when you're making your observations. Yeah, I consider refraction in every explanation I come up with. But I don't have to use a curved path of light to do it, because that is not justified under the laws of light propagation. I hope this helps a ton of people make other people's lives very miserable. Okay, because once we get beyond this nonsense, hopefully people's lives will be a lot better. Thank you. Goodbye.